Hi, I'm Pedro from Pedro's Garage, and today I want to talk to you about the infamous intermediate shaft bearing. What is it, what the problem is, and what the solution is. There's been a lot of misinformation out there, especially now that Porsche agreed to a class action settlement a couple of months ago. So it's a hot topic all over the forums. People are talking about it, they're expressing their views, and a lot of these people don't really have the technical background, and they're just saying things that they've heard secondhand or third hand, and the saying that if it's on the internet, it's got to be true. So a lot of people really think that it's true, and they take it to heart. And we're seeing some people really being hurt by some of the issues that are being put out there. Some of it is unintentional, but other is actually misinformation that is actually very intentional. So let me explain what the bearing is, what it does, and a little bit of the history. In 1997, actually 96, but it was model year 97 for the U.S., Porsche decided to make the water-cooled version of their engine. So they took what they call the new engine was the M96. Eventually, it became the M97, and they built that engine from 1996 through 2008. Um, Again, that engine had an intermediate shaft. And what's an intermediate shaft? Well, the intermediate shaft is the shaft that's its purpose is to um, make pass the movement from the crankshaft, the main crank, to the cams. So it's a shaft that gets moved from the main crank with some chains, and then from here you go to the camshafts. So you get the movement from the main shaft to the camshafts that way. So it plays an important purpose. Now, the intermediate shaft in these cars, again, it's in all the Boxsters, all the Caymans, all of the Carreras from 1996 through 2008. And this is an intermediate shaft. This was from a 1999 Carrera Boxster. I'm sorry. It's basically just a tube. It's a hollow tube, closed on one end, with a journal bearing or a flat bearing that rides on the engine. This side is right up against the oil pump, so this side gets a lot of lubrication, a lot of oil, and there's never been an issue on this side. The other end, which in the Boxster and Cayman points towards the rear of the car, but in the 996 points towards the front. This is the end where Porsche decided that they were going to put a sealed bearing in the end. That decision, I think, was a smart decision um, because sealed bearings have been known to last many years. They're extremely efficient. They're actually a lot more expensive than a standard flat bearing. I mean, this is a piece of engineering. The flat bearing is the first bearing ever built. So the ball bearing is actually quite a feat of engineering, and it's very efficient, and it should last hundreds of thousands of miles when it's properly lubricated. So Porsche put in a dual row bearing in the 97, 98, 99 Boxsters, and also in the 1999 Carrera. And then they made some changes internally with the VarioCam. They went from VarioCam to VarioCam Plus, so they needed to make some changes in the shaft, and they needed the room, so they came up with reducing the area, and now they came up with a single row bearing, which is half the area of the dual row. Immediately after they did that in 2000, engines started failing. Those were obviously brought back to the dealers. Most of them were under warranty, and Porsche started studying the situation. We hadn't known about it. We had just started hearing a couple of years after that from people coming on the forums and saying, "Just my engine just blew up," and another guy, "And my engine just blew up." And eventually, we figured that there was an issue. Um, in 2005, Porsche, when they came out with the M97 engine, which was a redesign, a little bit more modern than the M96, and that was again in all of the Caymans, all of the Boxsters from '05 on, right '05 on, and all of the Carreras from '05 on. Um, Porsche decided to put much larger single roll bearing. So it was a bigger bearing, this big around, which was stronger. They figured that the problem was the bearing, so they strengthened it, and that was a logical conclusion. Um, some aftermarket people again had the same conclusion, that the bearing was weak, that the bearing had a problem, and in particular, one of them, LN Engineering, decided that they would source a better bearing. So they went out on the market and they found a bearing that had steel races, the outer and the inner race, but they had ceramic balls that were more efficient, that would take the load better, and that would work better than the steel balls in marginal conditions. So they started promoting that the ceramic bearing. And better than that, they found a way, and they designed a special tool and patented it, that would allow the bearing to be extracted from the intermediate shaft with the engine in the car and the shaft in the car. Unfortunately, for the '05 and newer cars, the bigger bearing that Porsche put in there doesn't allow that to happen. So those people with the newer cars, with the '05s, '06, '07s, and '08s, you can't remove the bearing, you can't replace it unless you take the engine down and open the engine case, and it gets quite expensive. So those cars, you're basically stuck. The older cars, you can pull the bearing. But again, most people thought and blamed the bearing, and they figured it's a weak bearing, and that's the issue, and it's the bearing and the bearing and the bearing and the bearing. But something that we always thought was that there had to be something else aside from the bearing. Yes, the bearing was failing, but we weren't really convinced that it was the bearing that was weak. And we weren't convinced because some cars that were driven hard, cars that went to the track all the time, never failed. Yet cars that were garage queens that get driven maybe 4,000 or 5,000 miles a year, those have the highest failure rates. So it can't be that a car that's really raced hard at the track never breaks, and the car that never gets driven breaks with the same bearing. It didn't make sense. So it really, we figured that it wasn't the bearing that was at fault. There had to be something that was making that bearing fail. So we went through all sorts of analyses, and finally came up with a theory that said that it isn't the bearings. The bearing is not the problem. The problem is the lack of lubrication. And here's what happens. Because these bearings are sealed, again, Porsche put them in there with a lifetime's grease, they figured it's going to last forever. And in theory, it works that way. Porsche didn't manufacture these bearings. They're made in Germany by another factory, but they just sourced them. And what happens is that on a car with the correct oil level, sitting in a level ground or garage, the intermediate shaft is immersed maybe half an inch in oil. The oil level is right around here. So that bearing is partially immersed in oil. Cars that, they're sitting there, oil eventually goes through the seal into the bearing, and if the car's just sitting there, eventually it goes out the other end and gets into the shaft. So you have about an ounce and a half, or maybe 2 ounces of oil in this tube. And this is plugged on this end by the bearing. The other end is sealed. So imagine an ounce and a half or 2 ounces of oil in here, just turning and turning and getting cooked and cooked and cooked. This goes through all of the heat cycles of the engine. All of it. It's an internal combustion engine, so it generates quite a bit of heat. And that oil is just sitting there and getting cooked and cooked and cooked with no way to filter itself, to replenish itself. So eventually it becomes rancid, but even worse, it becomes acid. And once that oil is acid, you now have an acid working its way back into the bearing, from the shaft into the bearing, gets inside the bearing and dissolves that lifetime grease. Now this bearing is running with no grease in there, um, and it's sealed. No way to get oil in there, no way to get the heat out of there, and eventually, and also the fact that that oil is now acid, the acid starts to eat away at the surface of the steel balls and at the surface of the steel races, and it starts to pit them. And once that happens, that's the kiss of death. Once you have a pit in a steel cage, in the steel balls, they are going to fail eventually. So, Ellen Engineering, as I said, figured that if they would put a ceramic bearing in there that was stronger than the steel, and they would take the seal off, that eventually that oil that was there was going to lubricate the bearing, and that would be great, and it would work fantastic. So a lot of people bought into that. Um, they installed the bearing. I put one in my car at 203,000. I decided to check my clutch. I was one of those that tracked my car every other week. And when I pulled the clutch and the flywheel in my car and checked the bearing, my bearing was intact. Absolutely no wear, no discernible wear. But I wanted to be sure, and I wanted to have peace of mind. So I put the new ceramic bearing into the car, um, like a lot of other people. But even that ceramic bearing eventually had some failures. So uh, again, that supported our theory that it wasn't the bearing, that there was lack of lubrication. Uh, the the Some people say that, and Ellen Engineering is one of them as well, that they say that now because you don't have a seal on this end of the bearing, it actually looks like this. It's open. If you can see it, you can almost even see the steel balls inside. Um, if you don't have a seal, and now you're sitting in oil here, that's enough lubrication to get in there. But I have we did a little experiment where we took this bearing, we pulled the seal out, and we filled it completely with oil, mounted it on a motor that would spin it, and it took less than 1 second for this bearing to completely shed all of its oil. I mean, absolutely every single drop, to the point that you would put a paper towel under it and you would see nothing come out of it after a second or a second and a half spinning at 1100 RPM. Obviously, the car is idling basically at 1100, or idles at 700, but 1100 is very, very low. So once you get the car up to 3, 4, 4500, 5000 RPM, imagine there's nothing in there. And think of this as a blender. If you have a blender that's full of juice, you're going to have the liquid all the way up here. You start the blender, and as it starts rotating, that fluid in there is going to be dispersed, and now you have completely empty all the way down to the bottom. And that's exactly what happens with the bearing. Even if the bearing is rotating inside oil here, as soon as it starts generating speed, every single drop in there is shed out, and the oil cannot penetrate. So what's the solution? Well, that's what I'm really proud to be involved with. There's a company here in South Florida that I'm associated with, and together with them, the there's a new piece of engineering called the direct oil feed that was developed, DOF is for short, and this is basically a modified. It's patented. And it's basically a modified flange. This is the flange from the factory that originally holds the bearing in place. So as you can see, the original bearing goes into the flange, and that goes into the intermediate shaft, and it's bolted to the outside of the engine. So basically what the DOF is it's exactly the same concept. It's going to hold the bearing in place, the same bearing. But now, if you look closely, there's a little bit of a difference here from the DOF to the original bearing. Here's the original piece. It's symmetrical with the 3 points where it's bolted into the engine. And this is the DOF. And you'll see that right here, it has a little difference. That difference is basically a port where we can inject oil into here, And if you look at the inside of the bearing, you'll see this little orifice where the oil comes from. So this actually, now, when you take the bearing and you take the seal off and you put it inside the flange, you're going to get a stream of oil being shot directly into the balls at whatever the pressure of the engine is. So if the engine is running at 40 psi, 60 psi, you're going to get a stream of oil right into the race, right into the bearing, which is filtered oil and cooled oil. So you're going to reduce the temperature of the bearing, and you're going to have enough oil in there to keep it lubricated. We provide a full kit that has a high pressure hose that connects to the DOF and connects to a port on the engine that's actually there. Porsche supplied that, and it's a very simple procedure. You don't have to remove the engine from the car. Just taking down the transmission, the flywheel, and the clutch, the transmission, the clutch, and the flywheel, and you have access to the bearing. You pull the flange, you pull the flange. You don't have to replace the bearing. We generally say that if you went that far, you might as well replace the bearing. Just put a new one in there for peace of mind. Start with a clean slate. But better yet, the cars that can't get their bearings replaced because they have the big one in the 2005 that we talked about, those are the perfect candidates that need to put this piece in place right away. Because for them, the sooner you start injecting oil into that bearing, the sooner that bearing gets protected and doesn't have to wear anymore. So for anybody that has an 05 and a half, because they started doing it halfway through 05, so anyone that has an 05 and a half through 08 should really consider immediately installing the DOF in their car to, like I said, to stop any potential wear on that bearing. Cars that are older than that, so the 97 through 05 or first generation 05, we just tell them that whenever they need to get their clutch done, that's the time. Because you're going to be pulling the tranny down to replace the clutch. It doesn't cost any more in labor, maybe an hour, just to replace this piece and give you peace of mind. Our kit is very accessible. It's $800, and it includes the flange, it includes the hose, it includes the bolts, everything that the shop needs to replace that. And now you're going to have peace of mind, because this little gizmo here will be injecting the bearing, like I said, with a stream of cooled and filtered oil that will make it last forever. We have had these pieces, they've been tested in race cars, in street cars, in all sorts of conditions, and we have yet to be able to measure any wear in any of those cars. I have it in my car. We have it in several hundred cars now in the market, and basically any shop that works on Porsches can do the installation. We don't recommend it to a do-it-yourselfer. It's basically a professional installation that should be done, but it doesn't mean that somebody with the right tools, with the lift and all the safety features, they can probably do it. If they've been able to replace the bearing, they're certainly able to install the DOF. So there you have it. Again, just to make the point one more time, the problem is not the bearing. The problem has been the lack of lubrication. And then once you install the DOF, lubrication is optimal. Your car will last forever. So thank you for listening, and we'll try to upload some new videos to show you the differences. I'll put the video of the spinning bearing and how it dissipates all of the oil so you can actually see it. So I'll upload it very shortly. Again, thank you and happy Porsche.